Hello, AP Psychology students, and welcome to Section 4 of Chapter 6 on Sensation and Perception. We're going to look at the other senses today. So we're going to get it. We did vision, we did hearing, so we got a few more here. So let's talk about taste. Food. Our savory sensation, gustation as it's called, comes from the chemical stimulating thousands of receptors in your mouth. But taste is 80% smell. If you have a stuffy nose or if you have the coronavirus, you're not going to be able to taste. You can plug your nose and eat things, and then you don't really taste it. That's why little kids used to do this when they would take their medicine. The tongue, the throat, inside the cheeks, and the roof of the mouth, they all kind of sense things. You actually have taste buds in your lungs. That's why you can kind of taste smoke when you inhale it on accident. The papillae, it contains our taste buds. This is actually the Latin word for pimples there. Humans have about 500 to 10,000 taste buds depending on their tongue. Each bud has 15 to 50 receptors per taste bud. In that, your total taste buds diminish as you age. And so as you get older, things don't taste as good as they used to. They're not as powerful, they're not as potent. And so people, as they get older, have to do things to make their food taste better, add more salt or make it spicy. You guys probably learned there was 4 tastes. There's actually 5. You have sweet, sour, bitter, salty, and umami. Umami, which is kind of a richness, MSG, not really good stuff. But meat has that like a fattiness to it. I think this is pretty basic though. 25% of people are what we would call super tasters. I mean that they have extremely strong taste buds. You can test that at home if you take a sweet little packet, saccharin, little pink packet, put a little bit in your hands and lick it. And if it's sweet, you're normal. If it's overwhelmingly bitter, you're a super taster. And sorry, I tortured you a little bit. My bad. People eat with all 5 senses though. When you eat, you see the food, you smell it, you hear it sizzling, and then you put it in your mouth and you can feel the texture, you can feel the crunchiness, and then ultimately you taste it. And so we do eat with all 5 senses. Spicy food is pain in your mouth. And this is why spicy food is still very popular. As people get older, spiciness, you can build up a tolerance, but it doesn't diminish. And so spicy food is very popular. Salsa has outsold ketchup for decades now in our country because people love to say salsa, according to Jerry Seinfeld. So smell. The scientific term is olfaction. Olfaction, had a smell. P-U-P-U-P-U. Neurons embedded in a tiny patch of mucous membrane way up in the upper part of the nasal passage, which if you've had a coronavirus test, you know where that is. Not very fun. Signals go from the olfactory nerve to the olfactory bulb to the brain. It's hardwired into the brain. We have 10,000 smells that a human can detect. None are more basic than others, and so each one has a specialized smell. So like you have a cherry receptor in your nose, you have a vanilla receptor, you have a BO receptor. Weird. Richard Axel and Linda Buck won the Nobel Prize for discovering these thousands of kinds of receptor cells. Very cool. It is much stronger than the sense of taste. That's why taste is 80% smell. You only need 1/25,000th the amount to detect cherry pie from smell rather than taste. So the tiniest and small amount, we can say, well, hey, that's cherry pie, I can smell it. Versus you need a lot more to taste it. I think that maybe the researchers are going, I think I need another slice. I still can't taste it. Yeah, I need another slice. We need more pie. A person that has smoked for 10 years, because smoking is bad, okay, must quit smoking for 10 years before their sense of smell returns to normal. I'm not sure if it works that way the whole time. If you smoke for 1 year, it takes a full year, but smoking damages your sense of smell. It damages your sense of taste. Everything tastes like a dirty ashtray. So don't smoke and don't vape and don't be stupid, okay? There's also, they've done studies to link citrus smell and cleaning, which is a link to memory. They've tried to come up with super stink bombs for non-violent, non-lethal ways to disperse crowds, and they tried to find what's the ultimate smelliness. Let's move on to the senses of the skin. So your basic skin senses, we have touch, you can feel pressure, you feel warmth, you feel cold, you feel pain, you can feel itching, you can feel, tickling, and then other sensations like, soothing and things like that. So we also have painful burning and all that fun stuff. Warm and cold sensations together produce a warm feeling. So if you have like a twisted pipe, let's say, two pipes that are twisted, one's hot, one cold, and you grab it, not too hot that it would burn you, you would feel a warm sensation, which is kind of like when we take a shower, that hot and cold water is mixing, but it makes us feel warm. There are four types of receptors. You have free nerve endings, which can detect all three feelings in the skin. You have basket cells, which are cells at the base of the hairs that can sense pressure. So it's not, we have hairs for a reason. The tactile disc, they sense pressure once again. And then you have specialized end bulbs, which can also detect pressure. The sense of touch and movement is also connected. And yes, maybe this is a little offensive. Fail. That's why you always get picked last there, buddy. Yeah. So here's kind of what's going on here with your skin and your sense of touch and all that fun stuff. You can pause that and take notes if you need. So let's talk about pain. Even when the stimulus is removed, if you cut your finger or bang your knee, the pain remains. Like when I stop chewing the food and the food's out of my mouth, I don't taste it anymore. When the smell is gone, the smell is gone. When you take away the vision, I stop seeing it. But if I bang my knee and I'm done banging my knee, it still hurts. What's going on there? So this is the gate control theory of pain. Ronald Melzack and Patrick Wall came up with this. That pain goes through a gate in the spinal cord. The brain controls the pain. The gate, like, hey, open it up, send the pain in. It tells the brain there's something wrong. We have damage down here. We need to alert the body to stop doing what it's doing, stop the pain, and we got to fix it. We got to heal this. And so be careful because there's an injury. Thoughts and feelings can influence our reaction to pain. Expecting something to be painful, like if you get a shot and you don't like shots, can make it feel a lot worse. Mild pressure or stimulation can help in closing the pain gate. So if you bang your arm, what do? You rub it. Not very good, but it makes it feel better. It can actually close the pain gate. It oversimplifies or kind of overstimulates the brain to shut off that pain gate. Free nerve endings serve as nociceptors, which are pain receptors. It's the negative receptors. And I know we don't like pain, but we absolutely need it. There are a few rare people out there that don't sense pain, and it's very detrimental to them. It's very dangerous because they don't know when they injure themselves or burn themselves. So it's sent through rapid and slow neural pathways, these nociceptors. And so you actually, you'll have that initial pain, like when you're like, and then you get that second wave of pain, like, ooh, that really does not feel good. And so that's why people feel first and second pains. Now, to update the gate control theory, there's something called phantom pain or phantom limbs. People that have amputation still feel pain where their arm is, and their arm doesn't exist anymore, their leg doesn't exist, or their finger doesn't exist anymore. And so they've tried to figure this out. The pain persists in the amputated limbs or even in severe spinal injuries. And so basically what's happening is the brain is generating pain. That part of the brain that used to fire, that received messages in the parietal lobe from that part of the body, is still firing, going, hey, what's going on here? I haven't done anything in a while. And so they've kind of found unique ways to do this through mirrors. Like if somebody lost a leg, they can put a mirror between their legs and they look down and they see their leg and they see the reflection of the leg, and it makes their brain say, hey, my legs are there, and it turns off the pain. Because it doesn't block the pain gates. When you take a pain pill, it blocks, the neurotransmitters and all that fun stuff and the pain gates, but they're not there. They're not existent. So it's in the head. There's enormous variation that exists in how people tolerate pain. If you've ever seen a pain scale, those things aren't real because it's all subjective. What hurts you might not hurt me as bad, and vice versa. And so there's a lot of genetic, there's a lot of cultural factors. How do we express pain? Like when is it okay, or when are you supposed to stop crying if you get hurt? Little kids bump their knee. If you're 33 years old and you bump your knee and start crying, people are like, dude, what's wrong with you? Just suck it up and be tough. It also leads to endorphin production, and then people's expectations. Is this going to hurt or not? Your environment also factors in. And so, it's kind of funny with athletes, like baseball players, and I'm a former baseball player, they're kind of wimps. They get a hangnail or a blister on their finger and they go to the DL. They disable this. Or you have hockey players who get stitched up on the sideline. They go back in the game. They have no teeth and they're cool with it. It's just kind of a cultural thing. So kinesius, is the sense of body position and movement. Your equilibrium, your sense of balance, which is controlled by the vestibular tubes and the cochlea in your inner ear, there's liquid in there. And so that tells us that, hey, I'm upright. Just like a level, water always levels itself. I can have a sense of if I'm upside down or right side up based on the cochlea and the liquid in my inner ear. When you spin around and you get dizzy, that liquid is still spinning. It's still going around and around and around, and it causes you maybe nausea and things like that. So it relies on the 3 semicircular canals in the inner ear, which is very, very fun if you like getting dizzy. That's all I have for today for other senses. I hope you enjoyed this. Let me know if you have any questions.